Greetings everyone, my name is Rahul Mishra. Today the topic which we are going to discuss is tools and techniques used for mobile forensics. Let's have a quick recap on what mobile forensics is. Mobile forensics is a subset of digital forensics, the retrieval of data from an electronic source. Specifically, mobile forensics deals with recovery evidence from mobile devices such as smartphones and tablets. Today, because individuals rely on mobile devices for so much of their sending, receiving and searching of data, it stands to reason that these devices hold a vast quantity of evidence that might be interesting to investigators. We often think of mobile forensics in the context of law enforcement, but they are not the only individuals who might rely on evidence from a mobile device. The military uses mobile devices to collect intelligence when planning military operations or counter-terrorism efforts. Businesses may turn to mobile forensics if they believe their intellectual property is being stolen or an employee is engaged in fraudulent activity. Businesses have been known to observe employees' personal usage of business devices to prove unauthorized use. But of course, it's law enforcement that may make the most use of mobile forensics using electronic discovery to gather evidence on a host of crimes from identity theft to homicide. Mobile devices can provide all types of important data ranging from call logs and text messages to web search history and location data that shows where the device owner might have been at a given time. Mobile forensics is a branch of digital forensics, and it is about the acquisition and the analysis of mobile devices to recover digital evidence of investigative interest. All the phases from the acquisition to forensics analysis of the mobile device have to totally avoid non-alteration of the examined device. This process is not easy at all, particularly in mobile devices. There are a lot of problems that experts face while doing forensics on mobiles. The main reasons are: the continuous evolution of mobile device technology allows the commercialization of new mobile phones, which creates new digital investigative problems. Hardware and software for these types of mobile device analysis are numerous, but none is able to give an integrated solution for the acquisition and the forensics. Furthermore, mobile devices are able to contain plenty of digital information, almost like a computer. So, not only a call log or SMS messages as old mobile phones. Many of the digital information in a smartphone is reliant on applications installed on it, which evolve in such a variety that analysis software is not able to support them completely. Due to these problems, there are a lot of tools available for free or paid which serve specific purposes only. Now, what are the different techniques or approaches used by an investigator on a mobile device to extract information? For that, we must know what type of information is available on the mobile phones. For example, SMS, MMS, chat messages, backups, emails, call logs, contacts, pictures, videos, browser history, GPS data, files or downloads, downloaded Facebook, Twitter and other social media apps, calendar appointments, shopping history, financial information, music collection, driving directions. In general, there exists no standard for what constitutes a supported device in a specific product. This has led to situation where different vendors define a supported device differently. A situation as this makes it much harder to compare products based on vendor provided lists of supported devices. For instance, a device where logical extraction using one product only produces a list of calls made by the device may be listed as supported by that vendor, while another vendor can produce much more information. Furthermore, different products extract different amount of information from different devices. This leads to a very complex landscape when trying to overview the products. In general, this leads to a situation where testing a product extensively before purchase is strongly recommended. It is quite common to use at least 2 products or more products which complement each other. Mobile phone technology is evolving at a rapid pace. Digital forensics relating to mobile devices seems to be at a standstill or evolving slowly. For mobile phone forensics to catch up with release of cycles of mobile phones, more comprehensive and in-depth framework for evaluating mobile forensics toolkits should be developed, and data on appropriate tools and techniques for each type of phone should be made. For mobile phone forensics to catch up with release cycles of mobile phones, more comprehensive and in-depth framework for evaluating mobile forensics toolkits should be developed, and data on appropriate tools and techniques for each type of phone should be made available in a timely manner. The different techniques of forensics include: first is manual extraction. This type of extraction requires a lot of costly hardware, which mainly includes a camera fixed to a stand and connected to a computer. The manual extraction techniques allow investigators to extract and view data through the device's touchscreen or keypad. At a later stage, this data is documented photographically. Furthermore, manual extraction is time consuming and involves a great probability of human error. For example, the data may be accidentally deleted or modified during the examination. Logical extraction. This is mostly software based. In this technique, the investigators connect the cellular device to a forensics workstation or hardware via Bluetooth or USB cable. The computer, using a logical extraction tool, sends a series of commands to the mobile device. As a result, the required data is collected from the phone's memory and sent back to forensics workstation for analysis purposes. Hex dump. A hex dump, also called physical extraction, extracts the raw image in the binary format from the mobile device. The forensic specialist connects the device to a forensic workstation and pushes the bootloader onto the device, which instructs the device to dump its memory to the computer. The process is cost effective and supplies more information to the investigators, including the recovery of phone's deleted files and unallocated space. Chip off. The chip off technique allows the examiners to extract data directly from the flash memory of the cellular device. They remove the phone's memory chip and create its binary image. This particular process is costly and requires ample knowledge of hardware. Improper handling may cause physical damage to the chip and renders the data impossible to retrieve. Microread. This process involves interpreting and viewing data on memory chips. The investigators use a high-powered electron microscope to analyze the physical gates on the chips and then convert the gate levels into ones and zeros to discover the resulting ASCII code. This process is expensive and time consuming. Again, it requires ample knowledge of hardware and file systems. Now, what is rooting? What do you mean by rooting a device? Rooting is a process allowing users of smartphones or tablets and other devices running the Android operating system to attain privileged control known as root access within Android's subsystem. If your Android mobile is rooted, that means you are a super user on your Android cell phone and you got ability to customize or replace system application and setting the way you want to do it. Now, what are the advantages of rooting? First is cool applications. There are a number of applications which work only on a rooted Android device, like screenshot apps, overclocking apps, ROM manager, wireless tether for root users, root explorer, titanium backup, and many more. Second is speed and performance. We all know that kernels are behind the performance of the processor of your smartphone. So, if you change the kernel version, you can change your processor, and that will also improve the speed and performance of your smartphone. Next is increasing of battery life. There are many apps specially made for rooted devices which access system settings and increase the device's battery life by optimizing it to a great extent. installing unsupported apps. There are a lot of apps which are not supported by your device, but after rooting your smartphone, you can install them by editing your build.prop file. Build properties, also known as build.prop, is a file in system folder of your phone which defines the A to Z details of your phone's model, brand, Android version and so on. You can tweak build.prop to change the way your device behaves. Next is accessing data folder. By default, all apps store their important data in this directory, which is not accessible for a normal user. It can only be accessed if the device is rooted. This is very important from an investigative point of view. Coming to the tools used for the technique discussed previously. Microread does not need any software. Instead, it needs an electron microscope and ample knowledge of hardware and file systems. So, coming to the first part, which is tools for manual extraction. Certain tools available are Project a Phone. The Project a Phone imaging system offers a simple, portable and affordable way to transfer images from a handheld device to a computer. Fernico ZRT. It reportedly takes photograph of the screen and merges those photos with custom designed report templates. Because it is a physical capture device, it will not work with devices that are logged for which no password or exploit is known. EDEC Eclipse. Eclipse is a device screen capture, photo documentation and reporting tool. For logical extraction, there are a lot of open source as well as enterprise softwares available depending on what type of service you need. Some of the most widely used ones are, first is XRY Logical. It is a rapid extraction method to access and recover files live and file system data from the device right on the crime scene by communicating directly with the operating system of the device. Oxygen Forensic Suite. It is a mobile forensic software for logical analysis of cell phones, smartphones and personal handheld devices. It is developed by Oxygen Software. The suite can extract device information, contacts, calendar events, SMS messages, event logs and files. Lantern. Quickly extract, report and share vital data from Apple iOS and Google Android based mobile. The common tool used for hex dump include XACT, pronounced as XACT. XACT provides mobile phone forensic specialists with the tools they need to perform highly sophisticated physical data acquisitions from confiscated phones or memories and allow for the recovery of deleted information. Celebrite UFED Physical Analyzer. It provides unrivaled access to mobile data and reveals every segment of the memory of a device using advanced extraction, decoding, analysis and reporting functions. Pandora's Box. It is a forensic solution for decoding the raw hex dumps from the memory stores on mobile phones. Tools used for chip off are, first is FITA Digital Inspection Station. This basically contains soldering iron in order to safely remove chips for analysis. iSesmo Phone Opening Tool. This particular tool is specially designed knife to open iOS phones. We will do a small case study here. How Celebrite Pathfinder helped led Gulf Coast Technology Center from a vehicle theft to a double homicide. What started out as a car theft ring morphed into a vehicle theft ring and firearms theft ring. The firearms theft ring then turned into a firearms distribution ring on the street where the guns were being sold. The guns then led to 2 active cases of homicide. GCTC, also known as Gulf Coast Technology Center, and James Barber, who is police chief for the city of Mobile, Alabama at that time, used a full suite of Celebrite tools to collaborate between multiple agencies and uncover the whole story of investigation. Now, what were the key challenges here? First was to relate subjects involved in vehicle theft in one county to individuals perpetrating similar crimes in a neighboring county. Relate the vehicle thieves to those involved in a larger vehicle theft ring. Relate those in the vehicle theft ring to those suspects in a related firearms distribution ring, and relate those involved in the firearms distribution ring to two open homicide cases. Digital solutions deployed: Celebrite Pathfinder and Celebrite Premium. We will do a small case study here. Leicestershire police find a teenage girl's killer using digital evidence and digital intelligence workflows. With strong processes and technologies for accessing, managing and analyzing digital evidence, police in Leicestershire, United Kingdom used digital intelligence to disprove the suspect's claim of innocence, locate the crime scene and generate evidence that led to suspect's convictions for murder and online grooming. Now, what were the key challenges? Suspect's claim of innocence. Now, despite the discovery of incriminating evidence, the suspects denied ever physically meeting with the victim. Second, locating the crime scene. After the victim went missing, the location of the crime scene and body remained a mystery. Third, multiple suspects. After claims of innocence from the first suspect, another suspect was brought to light. Now, what were the solutions deployed here? The main solutions deployed here were Celebrite UFED Touch, Celebrite Physical Analyzer, Celebrite Responder, Responder Kiosk, Celebrite UFED Cloud, Celebrite Premium and Celebrite Advanced Services. We will do another case study here. Colombian authorities used digital evidence to convict high-profile suspect in child prostitution case. In 2017, the Sex Crimes Group of the Regional Division of Criminal Investigation of National Police in Colombia was investigating a child prostitution case in Caldas involving a doctor and a local politician. The prosecutor on the case turned to Fiscalia General de la Nación Computer Forensics Lab for help. Knowing from past experience that the lab and the lead technician would likely be able to uncover the digital evidence needed to not only tie the suspect to the case, but ultimately help convict them. Now, what were the key challenges? The key challenges were: gather digital evidence from two logged phones, a Samsung and a Huawei. Produce finding in just 15 days while the suspect was still in police custody. Create a compelling report that prosecutors could use in court to help convict the suspect. Now, what were the solutions deployed? The solutions deployed were Celebrite UFED and Celebrite Physical Analyzer. Now, we will discuss a case study here. An organization, for example P, received a complaint from a user Ali explaining that his mobile phone has been hacked. His contact list has been receiving text messages through a popular chatting application, WhatsApp. However, Ali claims that he has not been sending any messages from his mobile phone. After accepting the case, the investigators started looking at the logs and records of this incident and began a trace from Ali's internet service provider, also known as ISP. In the technical report provided by the ISP, there are two registers of messages for servers of mobile phones, the sender register and the receiver register. The report indicates that the messages were actually received by Ali's contact list. However, there was no record of his mobile having sent any messages. The mobile phone used in this case was an iPhone running iOS 5.0.1 operating system. Based on ISP's report, Ali is innocent in this case. However, there is a need to know how was Ali's phone was compromised and used to send messages to Ali's contacts. Ali's phone was not available for testing due to legal constraints. There was a need to simulate the events to better understand the ways by which Ali's phone was compromised. To carry out digital forensics and to better understand how such a compromise can take place, a phone from the same brand as Ali's phone should be examined and WhatsApp data should be extracted. There are many tools used in smartphones forensics. Two of the most popular tools are Oxygen Forensic Suite and UFED Physical Analyzer by Celebrite. Both tools are industry leading and widely accepted by forensics experts for providing accurate and verifiable results during forensics analysis. The ISP confirmed earlier that Ali did not send WhatsApp messages. On the other hand, Ali's contacts received WhatsApp messages from Ali's phone. To simulate the scenario, a similar device was tested using Oxygen Forensics and UFED Physical Analyzer. It was found that WhatsApp messages do not necessarily require cellular communication to be delivered. WhatsApp messages can also be delivered over Wi-Fi network. From the above mentioned facts, we can derive two possible compromise scenarios. The first scenario, let's call it scenario A, the subscriber identity module or the SIM card was removed and the attacker used Wi-Fi network to deliver WhatsApp messages. Scenario 2, Ali sold his smartphone but did not delete WhatsApp application and the new owner used a Wi-Fi network to deliver WhatsApp messages to Ali's contacts.